we're going to talk about K selection and R selection. And here's the difference. The goal of any species is to procreate, to have offspring, so that that species can survive, so the next generation of that species will survive and continue to flourish through the years. And there's basically two strategies to ensure this. The first strategy is for individuals in that population to have as many offspring as they possibly can, knowing that even though most of them aren't going to survive, most of them will be eaten, when you have as many offspring as you possibly can, some of them are going to live. That's one strategy. The other strategy is called K selection. I guess the first strategy we talked about is called R selection. And that's the one where you have as many offspring as you possibly can. And these two species, the gray squirrel and deer mouse, exhibit that. The other one, like I said, is called K selection. Now, K selection is the opposite. Instead of having as many offspring as you possibly can, you have very few offspring, but you put a tremendous amount of time and energy into providing for and protecting your offspring so that they're much more likely to survive to adulthood. In R selection, there's very little parental care. So once those offspring, once those babies are born, for a couple of weeks, they might be with their mother, but after that, they're pretty much on their own. So those are the two main strategies. R selection, have as many kids as you possibly can. Some are going to live. K selection, have few offspring, but take a lot of care of them. Examples of K selection, we have the elk and the black bear, and R selection, we have the deer mouse and the gray squirrel. You can see obviously one difference between the two is that K-selected organisms tend to be bigger. R-selected organisms tend to be smaller. Now they would show different growth patterns. Okay, so we have two different growth patterns that we're going to look at. We've got exponential growth and logistic growth. So let's take a look at exponential growth. Now exponential growth is what we would see mostly in an R-selected species. And you can see in exponential growth that after an initial period of slow growth, that population begins to grow quicker and quicker all the time. Which makes sense because, like we said, for R-selected organisms, they tend to have a lot of offspring. So it's not surprising that if you have organisms that are having a lot of offspring, that population can grow quickly in a short period of time. Now, just as an aside, this R, whenever you see R, it refers to a term called biotic potential. Now, biotic potential is a pretty important term that you need to know. Biotic potential refers to a species' ability to increase in population under perfect conditions. So an organism with a high biotic potential can explode in population quickly. So for example, rabbits. Rabbits have a much higher biotic potential than human beings. The reasons are, number one, a rabbit is sexually mature at like 1 or 2 years old. So at 1 or 2, they can start having their own babies. And they're pregnant for, well, I don't know how long, but it's a lot less than 9 months. And then when they do have babies, they have, 8 or 9 babies at a time in one litter. Whereas if we take a look at humans that have a relatively low biotic potential, they aren't sexually mature until at least 15 years or so. They can't have their own babies until then. When they are pregnant, they're pregnant for 9 months, which is a relatively long period of time. And when they do have offspring, in general, it's one child at a time. So humans have a low biotic potential because you can see for those reasons they don't really increase in population that quickly. So humans are K-selected organisms, and humans, among other things, show this type of growth pattern. This is called logistic growth. And you can see with logistic growth that population may start to grow slowly, then it'll start to increase more quickly, but at a certain point it's going to level off at a certain point. Now what that certain point is, it's called carrying capacity. And whenever you see that capacity, whenever you see that variable K, it is referring to the carrying capacity. So K-selected organisms generally exhibit growth that has a carrying capacity. Now what is a carrying capacity? Carrying capacity is basically the maximum number of individuals or the optimum number of individuals that can be sustained in a population. So the carrying capacity of, let's say, southern Alberta would probably be, I'm guessing, about 5 million people or so. Beyond that, then there's not enough food, not enough resources for everyone. So that would be, higher than the carrying capacity. So that's the difference between exponential and logistic growth. One more thing to note, logistic growth, you can see the growth curve kind of looks like a sideways S, so we call that an S curve. Okay, well, exponential growth kind of looks like a J, so we call it a J curve. And one more note to make about exponential growth, and that is that you can recognize that a population can't continue to explode in population forever. So what you normally see after a while, after a period of immense growth, is a population crash. And that's because when the population grows so quickly, all of those individuals use up all of the resources, and then there's none left for anyone. So everyone's got to either move away or they don't survive. And here are the basic differences between K selection and R selection. So in R selection, we have rapid development and reproductive rate is very high, sexually mature quite early, and they're quite small. In K selection, we have slow development, low reproductive rate, and they tend to be big organisms. A couple other things that might not be totally intuitive, these last bullets on either side. Well, we know that R selection shows the J curve with the exponential growth, and K selection shows the S curve with logistic growth. But the other thing is that R-selected organisms tend to be affected mostly by density-independent factors. And if you don't remember what density-independent means, it means abiotic. So R-selected organisms are most affected, their population is controlled mostly by abiotic factors, so temperature, precipitation, things that are not living. On the other hand, K-selected organisms tend to be governed mostly by density-dependent factors, and that is biotic. That is, things that are living. So things that would control or affect a K-selected population, definitely availability of food, disease, number of predators, things that are living.